Okay, now we're going to look at inequalities with absolute values. We are going to start off with some fairly easy examples here just to kind of get us to understand how these inequalities work here with absolute values, because they are a little bit tricky. So let's start with the absolute value of x has to be greater than or equal to 8. Now remember, absolute value is the distance from 0 that the number is. So I'm just going to draw a number line here, because if this was an equation, like absolute value of x is equal to 8, we'd know that there'd be just two answers here, and there'd be an answer of -8 and 8. Now we're just going to look at the graph here and look at the solution and help us see what the interval should be just by intuition, and then we'll talk about how we would solve these. Okay, so then what do we have here? Well, the absolute value of x has to be greater than or equal to 8. So we can clearly see, if we're looking at the positive ones, if I just go out to the right there, anything bigger than 8, 9, 10, whatever, 10.1, that's definitely going to be bigger than or equal to 8. Okay, now if we come here, this is where we have to maybe be a tiny bit careful. I'm talking about being bigger than or equal to 8, but it's the absolute value. So actually, I would look at all of the numbers going to the left of -8, because -9, for instance, absolute value of -9 is of course +9, and +9 is absolutely bigger than or equal to 8. Alright, so then just right here we have a graph of the solution. And what that means here is this is going to kind of guide us with how we solve these in general, is that we're going to have two inequalities that we get. We're going to get x, in this case, being greater than or equal to 8, or x, and because we're going to do a negative, when we multiply by negatives, remember we flip the direction of the inequality. So it'd be x less than or equal to -8. So this would be the inequality notation. Now, this is where you have to be careful, because in the previous video at the end, we tried to write these as one long inequality, and we can't do that here. And the reason you can't is I'll do it as an aside here. So if you can write it as one long inequality, we want to do that, but we can't here. And the reason being is if we write this, 8 would be, less than or equal to x, and x is less than or equal to -8. But then, wait a minute, if we tried to use the transitive property, this would say x is less than or equal to -8. Well, we know that's not true. So this just means we can't write as one long inequality. We have to keep it separate as two different inequalities with an or between it. Now, if we wanted to talk about interval notation, we would have this being 8, including 8 going up to infinity, union -infinity to -8 with a square bracket. Now you could write those in the other order. Typically, actually, we would put the -1 interval first. Okay, so let's look at another example here that's not really too much more difficult, but is something that's going to illustrate how the inequalities, when you cannot combine them into a single inequality. So let's look at the, let me scroll up a little bit here first, the absolute value of x over 5 being greater than 3. I'm sorry, not greater than 3. I'm not seeing my notes correctly. I want this to be x over 5, absolute value still. Oh, something happened here with my ink. There we go. What I want it to be is less than 3. That's the one I want. Okay, now we're still going to approach this how we kind of learned in the previous problem. We're going to have two inequalities here. We're going to have x over 5 being less than 3, or x over 5 being greater than -3. Now these are both so pretty simple to solve. Multiply both sides by 5. So x would be less than 15, or x would be greater than negative 15. So now the question is, can we write this as one inequality? Well, I'll do a little side computation here. So what do we have here? We have that negative 15 has got to be less than x, and x has to be less than 15. Now the transitive property would then imply that this is saying negative 15 is less than 15. But that is absolutely true, so we can write as one inequality, and we can write it as negative 15 less than x less than 15. So that would be the inequality notation. And then if we graph this, you'll notice that when we can write one inequality, there's really just one interval. And if we graphed this on a number line, we would have, again, not worrying about scale, we'd have two open circles, one at negative 15, one at 15, and then we'd have everything in between. And again, if we want to write this in interval notation, this would just be parenthesis negative 15 to 15. Alright, let's look at a couple more examples here that are slightly more challenging. I wouldn't say that they're difficult, they're just a little bit more challenging examples to look at. So then let's look at 1 minus 2x absolute value being less than 5. So we're going to solve this and then determine if we can write this as a single inequality. And if you can write it as a single inequality, I want you to do that. Alright, so what do we have here? Well, we get two inequalities to solve. We get 1 minus 2x being less than 5. And then we have 1 minus 2x, switching the direction, has got to be greater than negative 5. There we go, negative 5. Now we just solve both of these. So this would be negative 2x is less than 4. Divide both sides by negative 2. Now of course we're dividing by a negative number, so that means I flip the direction of the inequality. So x is going to be greater than negative 2. And then I'll solve this other one. Subtracting 1 from both sides, I have negative 2x is greater than negative 6. Divide both sides by negative 2. Again, I'm dividing by a negative, so I flip the direction of the inequality, and I get x is less than positive 3. And then to kind of see again, what we do is we'd write negative 2 less than x, x less than 3. We always want to have it so the x's are in the middle, like this, and the arrows are going to the left opening. And so what we get then is we ask ourselves, okay, this would imply, using the transitive property, that negative 2 is less than 3. Well, that's absolutely true. So we can write this as a single long inequality, as negative 2 being less than x being less than 3. And of course you could graph this and also do the interval notation, which I'm going to skip for now. Okay. Let's look at, actually we'll look at two more examples. One that's actually, the last example we'll look at is kind of a sneaky one. It's actually very easy. You won't see it show up too often, but it is something you have to be careful of. So we have 3 times the absolute value of 4 minus 5x being greater than 9. And again, we're going to want to see if we can write this as a single inequality once we get to our solution. Alright, so then first off, before I do the positive and negative, it's always good just to get the absolute value isolated. So we divide both sides by 3 and get the absolute value of 4 minus 5x is greater than 3. And then, well, we'd get our two inequalities. 4 minus 5x is greater than 3. 4 minus 5x, switching the direction, is less than negative 3. Now, just go ahead and solve this. Now, I'm going to solve this a different way than we have in the others, because I would have to eventually divide by a negative. If you don't want to do that, you can just add things so that you don't have to divide by a negative number. And what do I mean? Well, I'm going to write this as 4 is greater than 3 plus 5x. So I added 5x to both sides. Then I'll subtract 3 from both sides, and I'll have 1 is greater than 5x. And in the end, I didn't have to flip a direction. And I still get the correct answer, which is 1 is greater than 1/5 is greater than x. Now, I won't bother on this one because, as I said, dividing by negatives really, in my opinion, isn't that big a deal. So let's write this as negative 5x is less than negative 7. Divide both sides by negative 5. So we get x then, flipping the direction, would be greater than 7/5. Okay, so again, let's see if we could write this as a single long inequality. So we would have 7/5 is less than x, and x is less than 1/5. But then transitive would say that 7/5 is less than 1/5, but this is not true. So since that's not true, we can't write it as a single inequality, so we have to write them as separate ones. So we can write x is less than 1/5, or x is greater than 7/5. And that would be our answer. Now, as I said, I wanted to do one other kind of sneaky example here. Let's look at this one. It's a relatively simple looking absolute value. X over 10 is greater than negative 5. Well, let's think about this for a second. As we said, a computational way of doing absolute values is always making everything positive, right? Well, that means any value of x I put in here is going to wind up being either 0 if I put 0 in, or a positive number. Positive numbers are always bigger than negative numbers. And so this is actually true for all real numbers. So the solution is all real numbers. And if you're not convinced of that, just plug in lots of different numbers. Negative 1, negative 1/10. What's the absolute value of negative 1/10? 1/10. 1/10 is a positive number. That's absolutely bigger than a negative number. So on and so on. You can plug in any number and you'll always get something bigger than negative 5. Now, we can do a very similar one if we have, for instance, x over 3 being less than, let's say, negative 2. Now, before you go through and solve this, you want to ask yourself, does this make sense? Well, can an absolute value ever be negative? No, absolute value can never be negative. So if it can't be negative, what's something less than negative 2? Well, something less than negative 2 would, for instance, be like negative 3. Anything less than negative 2 is going to be another negative number. So there's no way I can get this to have a solution. So it turns out this has no solution. So when do we have to be careful? Well, we have to be careful if we have negative numbers on the other side of the inequality, and knowing whether or not I will have no solution or I might have all real numbers as solutions. Alright, this wraps up this video on inequalities. We still have a couple more that we need to get through dealing with inequalities, and we'll look at those here on the next set of videos.